All right, guys, I'm back. Um, I guess I wasn't signed into that program and it shut me off just before I got so rudely interrupted. So I apologize for this, and I'm not going back and redoing all that stuff. I guess it's just going to be two different files. I'll combine it into one. Take the previous term right here, whatever the previous term is, add 10 to it. Here we go, second part of example number one, or this example number two, I guess. I think this was, is that a ratio? Add 60. Yeah, it's definitely a ratio. Was it 16 and 40? Did I copy that right? Multiply it by. Yeah, yeah. Because here we go, 40. Sometimes we got to cheat a little bit, right? 40 over 16 is 2.5. 100 divided by 40 is 2.5. So this was times 2.5. This is times 2.5. So again, we got to establish the first term. A sub 1 equals 16. You got to establish what that first term is. And A sub n is equal to, bear with me, sorry guys, this is amateur hour. A sub n is equal to A sub n minus 1. Take the previous term, and all we do is multiply that times 2.5. We can put that in parentheses if you want. If you'd rather do that, that looks better. Okay, let's see how we did. Drive 7.5. Sorry, y'all aren't supposed to be watching all this stuff. There we go. No, they rewrote it. They wrote 2.5 times a sub 1 n minus 1. That's okay. That's okay. Notice again how they did the first term. All right, write the first five terms of these guys. So here's a sub 0. Now, a sub 0 is not the first term. So you got to plug in 162 in here times 0.5 to get the first term. Okay? A sub 0 is not the first term. A sub 1 is the first term. Write a recursive rule. So there's your clue. You got to know the words. Recursive means you're using the previous term. You're reusing the previous term. And explicit means just that. You're going to write an explicit rule for that. Okay? Recursive is actually, I think, a little bit easier. Write a recursive rule for this. Now, these are special sequences. So let's look at this. This is example number 3. This is a 1, and then a 1, and then a 2, and then a 3, and then a 5. Dot, dot, dot. And B is a 1, and a 2, and a 6, and a 24. Okay? So let's go down here. This is example number 3. A. All right? A sub 1 equals 1. That gets you, I wouldn't say half the problem, but it comes close to it. A sub n equals A sub n minus 1. Now we're real close. Now, what are we doing to the previous term? 1 to get 2, 2 to get 3, 3 to get 5. So look. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. So what you're doing, A sub n, you're taking the previous term and adding to that the current term. How am I going to write that? A sub n, I think. So let's do this. A sub 1. This would be A sub 0, which I don't know what that is. So A sub 2. 2. 2 minus 1 is 1. A sub 1 is 1. A sub 2 is 1. No, A sub 2, I need to get 1. Because this is A sub 1. Oh, no, you're good. A sub 2. Yeah, A sub 2, I'm supposed to get 1. Oh, I'm going to get 2, though. A sub 3. A sub 3. This would be A sub 2, which is 1. A sub 3, which is 2. I need think I want to do that. A sub 3. This would be a sub 2 and a sub 1. So this is 1, 2, 3, 4. This is a sub 5. So a sub 5, this would be a sub 4, which is 3. So a sub 5 will be 3 plus 2, which is 5. That works. So see how we're doing on that one? We've got to do a sub n minus 1 and a sub n minus 2. Some of these are harder to see. But this one you can't write as a geometric because there's not a common difference and there's not a common ratio. Okay? All right, this one. 1, 1, 2, 6, 24. I happen to see it. 1 times 1, 1 times 2, 2 times 3, 6 times 4. So this is times 1, this is times 2, this is times 3, this is times 4. And this is the first term, this is the second term, this is the third, this is the fourth, and this is the fifth. So here we go. A sub 1 equals 1. Again, you always have to do that. A sub n equals a sub n minus 1. That's the previous term. So what do we do to the previous term? Well, the previous term, we multiply it times. Do we multiply it times? I think it's going to be n minus 1. A sub 5. A sub 4, which is 6. A sub 5. 5 minus 1 is 4, 24. Yep, that works. I don't have a good way of explaining how to do this. You just kind of have to see this. And I always check that last one. I don't ever check the first one, the second one. I always just check that last one. So a sub 5. This means 5 minus 1 is 4. I need a sub 4. So a sub 4 is 6. 5 minus 1 is 4. So 6 times 4 is 24. That works. You kind of see these or you kind of don't. That's why I don't really like this. Yep, there it is. A sub n minus 2, a sub n minus 1. I should have looked through this probably before I taught it. Oh, they just did n. Oh, you see what he did? They did the a sub 0 is equal to 1. So they changed that up. So I think mine works. Okay, example 4, multi-step. That's a word problem. I'll let y'all deal with that one. Guided practice. Iterate a function. Find the first 3 iterates. Oh, here's iterates. Iterates involve repeated composition of functions within itself. The result of one iteration is f of x. The result of 2 iterations is f of x. Holy cow, I've never heard of this in my life. You can use iteration to generate a sequence recursively. Begin with an initial value f sub 0, let x sub 1 equal f of x sub 0 and x sub 2, and so on. So here's the function. So I'm going to, x sub 1 is I'm going to do x sub 0. X sub 0 is 2. So I've got to plug in 2 for x. Okay? Get negative 5. Then I'm going to plug in negative 5 for x and get 16. Then I'm going to plug in 16 for x and get negative 47. So you see what I'm doing here? They make this sound a lot worse than it is. You find the f of 2 to find that x of 1 because they gave us x of 0. Okay? If they gave me x of 1, then I would just plug it in to get x of 2. So 2, you plug in 2 in for x and you will get negative 5. You plug in, bear with me. Now, can I go here? No, I didn't do that. I just took a picture of that. Capture a still image. I did that. I don't know how to do this. That's not working either because I'm not on it. I don't know. I want my board. All right, plug in -5 for x. So -3 times -5 is -15 plus 1 gives me 16. Then plug in 16. So -3 times 16 is -48. -48 plus 1 is -47. Iterates. That sounds like I'm calling you an idiot. Iterate. You're an iterate. All right, I'm done. Sorry, guys. All right, here you go. Here's your homework, right? Write the first 5 terms. So here's the first term. Recognize this one now. This is the 0 term, so that's not the first term. So plug in the 0 to get the first term. Okay. Multiple choices here. Write a rule for these. Some of these are difficult. Some of them are not. You kind of either see it or you kind of don't. And then iterate functions. Write the first 3 iterates. So here's plug in -2. Whatever you get, plug it in. Whatever you get, plug it in. Okay. -3, plug it in. All right. So that shouldn't be too bad. All right. Enough being done there, guys. Oh. Hopefully you got your 7.3 turned in. Hopefully you did. This is 7.5. So far this chapter, we've done 7.1, 7.2, 7.3, 7.5. Most everybody. Now, again, if you don't get it in on time, I'm emailing you and your mom. And most of the time, it's just a reminder. I know a lot of times you get it and you just forget to hit submit. Sometimes you just forget to turn it in. I get it. It's okay. I'm just sending out reminders. I want you guys to stay on top of your work. I probably should have been doing that all dang year. And then I'm not too sure what else we got going on, but this is all we're doing here. I think we're a little bit ahead of the other class. I know that surprises you guys. We kind of always seem to be that way. That's just the way I roll. Um, that's because That's because you guys are a lot smarter than the other classes. That's all there is to it. I miss you guys a bunch. What do you call? I don't know if I told y'all this one. What do you call a can opener that doesn't work? I'm gone. See ya.